Hi, I'm Miss Hearn. Welcome to my channel. Remember to like and subscribe.
All right, so some of the stuff we're going to talk about today might be stuff you've seen before. Everybody has different backgrounds when it comes to trigonometry. Some you might not have seen any of it before, and that's okay. That's why I'm starting with the very, very basics, okay? The first thing we're going to talk about is what exactly do we mean by an angle? An angle is formed by two what? Does anyone remember from maybe geometry what these things that are these arrow things are over here? You have one says initial side and one says terminal side. Yes.
Rays.
Rays, very good. Formed by two rays that have a common what? Where do they meet? At the vertex, right? So they have a common vertex. One ray is called the initial side, and the other is called the terminal side. And I will be emphasizing vocabulary a lot. I think it's very important that we understand the words that we're using. And it's easy to overlook that and focus just on the mechanics of the problems. It's these two rays joined together, but it's also about the space between them, right? How opened or closed this object is, that determines how big of an angle we're talking about. We generally label angles using a lowercase Greek letters, like the one here is theta, but we also use alpha, beta, gamma, phi, and other lowercase Greek letters. And so when you hear me say those words, you need to know which of those variables I'm talking about. So if you're not familiar with those letters, you need to get familiar with those. All right, now when we talk about angles, usually it's most useful to us in the context of the XY coordinate system. And we have a standard way of positioning the angles so that we can analyze them. And an angle is said to be in standard position, which is a term that you need to know. If its vertex, the point at which the two rays meet, is at the origin, 0, 0, in the rectangular coordinate system, and its initial side is on the positive x-axis. So if I draw an angle in the xy coordinate system, generally what I will do is start at the origin and draw the initial side. And then I will draw the terminal side wherever it is that I want it. And then you have to draw this little arrow. You'll notice there's a direction to it. And it always goes away from the initial side. So if my angle starts at the positive side of this x-axis, and that's my initial side, and this is my terminal side over here, the initial side is always on the x-axis. This arrow that shows how big the angle is, this one has to go in that direction. You never have it going from the terminal side up to the initial side. It has to point at the terminal side. And you can have angles that go more than one time around the circle, like this one here. So here's the initial side, and the terminal side is here, but the angle is actually going around and then up past the end of the circle again. So drawing that little circle tells us how big the angle is. If I had drawn it just like this, that would be a different angle. Okay, so those are angles. So in this example, we're just going to discuss it. Explain to me, somebody, why angle theta sub 1 is considered to be not in standard position. One on the left, theta sub 1. Why is it not in standard position? Yes.
Because the initial side isn't on the x-axis.
That's right. The initial side is not on the positive side of the x-axis. So for theta sub 1, the initial side is not on the positive x-axis. Okay, and are we on receipts? Oh, okay.
Oh.
Now let's look at theta sub 2. Why is theta sub 2 not in standard position? Well, remember, the vertex has to be located at the origin. So for theta sub 2, the vertex is not at the origin.
All right, so angles are measured by determining the amount of rotation from the initial side to the terminal side. So you tell me, a complete rotation around the whole circle would be how many degrees? 360 degrees. 360 degrees, which the symbol is the little circle. Have you ever wondered why they use 360? Never occurred to you, like, why would they pick that number? But I'm pretty sure one of the reasons, similar to the reason why we have 12 hours on the clock and 12 months in a year, is because it's easy to take a half, a third, and a quarter of multiple of 12. We have some names for angles based on their size. So for example, what is an acute angle? An angle less than 90 degrees. That's right. Now 90 degrees is a quarter of the way around the circle, right? So 90 degrees, if this is 0 degrees, if we go a quarter of the way around the circle, we would get to 90 degrees. So an acute angle is anywhere in between there, is going to have its terminal side anywhere in between there. I'm going to call this acute angle alpha. And what we know about alpha is it's definitely bigger than 0 degrees and it's definitely smaller than 90. All right, what is a right angle?
90 degrees.
90 degrees. And what is a common way that we indicate we have a right angle? The little square thing, yeah, right there. So this is a right angle. This is actually equal to 90 degrees. What is an obtuse angle?
Greater than 90,
but less than 20.
Very good. Greater than 90, but less than 180. So where's 180? 180 is over here, right? We have 0, we have up to 90 is a quarter of 360, and then another quarter would bring us to 180. So he said it's greater than 90, but less than 180. So it's somewhere going to have its terminal side somewhere in, what is that quadrant, by the way?
Quadrant 2.
Quadrant 2, yes. Remember the quadrants, we number them Roman numeral 1, 2, 3, and 4. So obtuse angle would fall somewhere in quadrant 2. So if I give this, say, the name beta, then what do we know about beta? Beta is between 90 degrees and 180 degrees. That's an obtuse angle. And then a straight angle. What is a straight angle talking about?
180 degrees.
180 degrees, that's right, which forms the initial side and the terminal side are collinear. They form a straight line. Have you ever thought about why an acute angle is called acute? Have you ever heard the word acute used in any other context?
Acute trauma.
Acute trauma, acute pain. What does it mean when I say I have an acute pain? Sharp, right? Strong, sharp. Okay, well, what about an acute angle is sharp? It's small, so it's pointy, right? So it's a sharp, pointy angle, so it's an acute angle. Although I know a lot of my students prefer to remember that it's little and cute, but that's not where it comes from. What about obtuse? Have you ever heard the word obtuse used in a different context outside of math? It might be used in medical terms. I'm not sure. I have heard it used as an insult. Oh. If I call you obtuse, what am I saying? Dull, dull-witted, dumb, obtuse. So why would obtuse be used for an open angle? Because it's dull. It doesn't come to a sharp point. Okay. So a lot of working with angles is going to come down. Your success with that is going to come down to how comfortable you are drawing little diagrams of angles. And we will be working with both degree measurements and radian measurements. And so in each case, I'm going to take the time to get very comfortable with it and how to draw the angle, given an angle, how to draw it in the XY coordinate system. We're going to start with just the top half of the XY coordinate system up to 180 degrees, but after a while, we're going to draw any kind of angle that we want. The angles we're going to focus on mostly today and for most of the semester are what are called special angles. So multiples of 30 degrees and 45 degrees are considered special angles. They're very useful for helping us find the exact values of certain things we want to measure. We have to get very comfortable drawing multiples of 30 degrees and 45 degrees in the XY coordinate system. So I just want you to think about this. if you divide that half of a circle, 180 degrees by 30 degrees, how many equal sections does that make? Make 6 equal sections, right? We have the 3 that are to the right of 90 degrees, 3 equal pie pieces. And then we have the 3 that are on the left side of 90 degrees, 6 equal sections. If you divide 180 by 45, how many sections do you get? 4. You have 4 equal sections, right? 45 plus 45 brings you to 90, plus 45 more gives you 135, plus 45 more gives you 180. We have 4 equal sections. So when you're asked to draw a picture of 45 degrees, or let's take one that's a little more challenging, 135 degrees, knowing that it's one of these special angles, knowing that it's a multiple of 45, I want you to think in terms of quarters of the semicircle there. So how many times does 45 go into 135? 3 times. So you're using 3 of these quarter pie pieces, and you can very accurately represent your angle of 135 degrees. You have to get very comfortable with that. Now, another way that you can draw it is including both the multiples of 45 and the multiples of 30 in one chart. You can actually do this by dividing the semicircle into 15-degree segments, but the only problem with that is 15 degrees, 75 degrees, 105 degrees, and 165 degrees. Those are not considered special angles, so you have some extra ones there that you gotta skip. But if you take these 2 and put them together, this is what it looks like, the black lines on this chart. That's all the special angles. So what you'll see in when you're doing your homework in my labs is they'll have a drawing that's something like this on the screen, and it'll have 3 marks in each of the quadrants. You'll be like, what the heck is that? Those are referring to the special angles, right? So in the first quadrant, the 3 special angles here are the 30, the 45, and the 60. 90 is also, are we out of chairs now officially? 90 is also a special angle, kind of a double special angle. It's 3 times 30 and it's 2 times 45. What would be the next special angle that they're indicating here? 120, and then 135, and then 150. Okay, and then 180. We'll talk about the rest later, but you see, you have to be able to know what they're referring to. So they'll say, they'll give you a point. They'll give you the diagram will not have these labels, and they'll say that there's a point here that's on the terminal side of what angle. There's no other reference, so you need to know that it's 135. It's the middle one out of those 3 special. From day 1, you need to start familiarizing yourself. So if you can recognize what multiple of 30 or 45 you have, you can draw a picture of it. So let's write each of these angles as a multiple of either 30 or 45, or both. What about 60? Is it a multiple of 30 or 45? 30. It's just 30 degrees times 2, right? What about 225? The multiple of 45, right? What multiple of 45 is it? 5, good. How about 330? 30 times what? 30 degrees times 11. Okay, so why is that important? Well, let's say that I asked you to draw 60 degrees. Well, that's really one of our special angles anyway. But if you think of dividing this into 6 sections on the top there, they're each going to be 30 degrees, remember? 6 sections, 30 degrees. So 30 times 2 means we're going up 1, 2. So you know I'm talking about this angle. And even though we haven't talked about angles that are bigger than 180, I bet you could draw this one, right? How do we divide up the top half when we have multiples of 45 degrees? Okay, so we're going to divide it into quarters. 1, 2, 3, 4, okay? And we're going to keep going. You have to divide the bottom half in quarters as well. Once you have it divided into quarters, how many quarters do we have? How many pie pieces? 5. So we're going to go 1, 2, 3, 4, 5. So 225 would have to fall down here, which makes sense because it's bigger than 180, right? So it's very important that you know how to draw angles that are multiples of 30 and angles that are multiples of 45. Now let's talk about radian measure.
And that's what we're gonna do in the next video. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.